The production of steel is responsible for roughly 7% of global greenhouse gas emissions. With half of all steel going into construction applications, engineers play a huge role in reducing that footprint. So what can we do to design smarter and build greener? Welcome to the ArcelorMittal International channel, where we talk all things structural steel. One solution to this problem is ASTM A913, a high-strength, low-alloy structural steel with a yield strength up to 80 KSI. A higher yield strength means engineers can achieve the same load-carrying capacity with a smaller section size. For strength-controlled applications, like gravity columns, long-span transfer or outrigger trusses, and steel concrete composite elements, this can reduce the amount of steel required by more than 30%. We can see this concept applied in this gravity column example. Under a given loading and unbraced length, the size of the steel column is reduced as yield strength increases, all the way up to a 32% weight reduction utilizing A913 grade 80. Simply put, less steel means a lower carbon footprint to produce materials and a lower embodied carbon for your project. That's only part of the story, though. ArcelorMittal produces A913 at its Differdange mill in Luxembourg, using an electric arc furnace with 98% recycled scrap. To understand why this matters, we need to talk a little bit about steel production. There are multiple ways to produce steel, and the method will have a significant impact on the carbon footprint of the steel product produced. The most carbon-intensive method is the blast furnace basic oxygen furnace, where most of the emissions are associated with the reduction of iron ore using coal. Using direct reduced iron in an electric arc furnace is significantly less carbon intensive, as natural gas is used to reduce iron ore into DRI and electricity is used to melt the DRI. However, the least carbon intensive method is using recycled scrap in an electric arc furnace. When scrap is used as a feedstock, there is no iron ore to reduce, eliminating the need for coal or natural gas-based reduction. That also means that A913 falls on the far end of the spectrum. But there's still more to this story. Electricity. In scrap-based EAF steel production, the electrical grid is typically the largest source of embodied carbon. When the grid relies on fossil fuels, the carbon footprint of EAF steelmaking can still be relatively high. But when the grid is clean, the footprint drops dramatically. That's why ArcelorMittal Differdange stands out. Most of its electricity comes from low-carbon nuclear or renewable sources, allowing A913 to be produced with significantly lower embodied carbon than the same process in regions powered by coal or natural gas. This is where everything comes together. First, A913 reduces the amount of steel you need. Second, the A913 that's produced already has a lower embodied carbon because of the process and the electrical grid. Stack these benefits together, and you can maximize embodied carbon reductions on your project. We can still take this a step further with ArcelorMittal's XCarb recycled and renewably produced steel. With XCarb, ArcelorMittal can produce A913 with 100% renewable electricity, driving embodied carbon to its lowest possible level. This design methodology also aligns with the goals of LEED v5, which places a much higher emphasis on embodied carbon reduction than previous versions of LEED. This strategy can be used most effectively with the Materials and Resources Credit 2, specifically with Option 1 and 2. For Option 1, A913 can be used in conjunction with low embodied carbon steel to show a reduction through a whole building life cycle assessment. For Option 2, procuring low embodied carbon steel alone can help achieve credits through EPD analysis. Credits achieved through Option 1 and Option 2 individually can also be stacked, which can be used effectively to maximize credits in this category. While a 40% reduction may seem difficult to achieve, when you consider the combined effects of A913 and low embodied carbon steel, the reduction can be in excess of 70%. That's all for now. Make sure to like and subscribe to stay up to date on the latest and greatest in structural steel.